Hello, everyone, and welcome to this CIVICA Data Science Seminar. Today, we're hosted by the LSE Data Science Institute. We're proud today to welcome Dr. Omar Guerrero, to lead today's event. Omar is the head of the Computational Social Science Research at the Alan Turing Institute, and he leads the policy modeling theme at the Turing's Public Policy Program.
And well, if you have not heard about the Alan Turing Institute, very quickly, I will tell you that it is the National Institute for Data Science and AI in the United Kingdom. And the group that I lead at the Institute works on topics related to social sciences, but indeed applying computational methods to analyze them, and also to try to bring this knowledge to policymakers. So we try also to develop tools that could generate some impact in the real world. So following these principles, I want to give you a presentation today that relates to one of these projects. It's called Policy Priority Inference, and it addresses the problem of modeling sustainable development. And I want to emphasize the talk according to this structure. So first, I want to motivate a little bit where I come from with this project. Then I will tell you a little bit about the methodology that we have developed, the philosophy, the ideas behind it. And then I will emphasize on applications to the real world. So we have developed several policy projects with international organizations and different governments. So I will show you a little bit of this so you get an idea of what these kind of methods can do today to generate impact without leaving behind the academic side. So I will mention a couple of the most recent academic works. And hopefully this will generate some interest in you to have a very rich Q&A afterwards. Okay, so let me begin with the problem that we have at hand. If you study development, you probably come from one of these three big groups. One is development economists, who probably is the oldest group. They typically look at GDP growth, unemployment, income per capita, very, very focused economic questions and variables. The other group, which is probably larger and more diverse, is the one that is known as development studies, or in the Americas is known as international development. And here you have a variety of professions: political scientists, anthropologists, sociologists, well, obviously development scholars, looking at a diverse set of policy and development dimensions. And then a more recent one, which is sustainable development, obviously comes from a more environmental perspective, but now is looking into understanding how the environment affects societies and how societies affect the environment, and how we can deal with things like the planetary constraints while trying to develop as a society. Well, while these three communities have historically been quite separated, they have their own journals, their own conferences, there are some things that they have come to agree with the years. And one of them is that development is a multidimensional problem. And more recently, it has been agreed that these dimensions are not just many, but they are not siloed. They are interdependent. They affect each other. There are spillover effects. And this is quite an innovation that you can see today, even in large international development agendas. Perhaps the most visible one is the Sustainable Development Goals, which I'm sure most of you know about. This is just the leading development agenda of the United Nations, agreed upon by all the member states. It comprehends 17 broad goals, which at the same time are subdivided into 169 targets, which at the same time are evaluated or tracked through more than 200 indicators. While these 200 indicators or so are the official ones approved by the UN and the member states, every country has additional indicators or different ones that suit their particular needs. And the important part about these SDGs, of course, part of it is that of the innovation has to do with the incorporation of the environmental dimensions of policy, inequalities, etc., but also with the acknowledgement that these dimensions are interrelated. And you can see this in the founding document of the SDGs right away in one of the first paragraphs, acknowledging that there are interlinkages between these many policy and development dimensions. Now, let's talk about how do we address this complexity this multidimensionality and their interdependencies. So again, if you come probably from an economics background into development, you are familiar with this type of models. This would be a regression model where the dependent variable typically is GDP growth, and the independent variables would be things like income per capita, for example, for a given country. Perhaps some policy variables, like these are variables that supposedly the government can affect, for example, literacy rates, and all sorts of controls and institutional variables that you can think of. And there are many criticisms to this approach. The most obvious one, and this comes from the community, the second community of development studies, is the lack of a multidimensional view. This is not new, but then there are other questions that have come up in the discussions in more recent years. So one is, for example, are all these covariates, income, literacy rates, etc., really independent from each other? Are the policy variables really random? Because the assumption that you have randomness and certain variation in the data is necessary to estimate these models, but policy variables, they are the result of intended actions from governments with very clear, very well-defined, although not always well-defined, but very narrow objectives. And another criticism is, are these models really context-specific? Because the data that you need to estimate these models is normally development indicators that are collected every year. So you wouldn't have enough data to estimate a model with 10 or 20 covariates. And if you want to account for interactions, it's even worse. So what you need to do is to pool cross-national data. So the coefficients, your A, B, C, would really be the coefficients of a hypothetical average country. So there is no context specificity in the kind of advice that you could derive from this sort of models. And then obviously some of these criticisms can be addressed. For instance, the lack of independence between the covariates could be addressed with interaction terms. But if you have too many policy dimensions, then you very quickly are going to run out of data if you want to account for all potential interactions. So there are clear limitations to these models. And in particular, the one limitation has to do with the fact that these policy variables are really not variables that can be directly intervened by governments. So what I mean is that literacy rate is not something that the government can just change, as you would do, for instance, in a clinical trial where you can change the level of some drug, right? What the governments do is they fund programs that are aimed to affect those policy variables. And these programs could be highly inefficient and in the end not produce any effect at all in the intended policy variable. So these programs are implemented at the micro level, again, not necessarily in efficient ways. And the way their performance is evaluated is typically at the aggregate level. So literacy rates are population level measurements, right? And that means that the outcomes that we observe at the macro level are the result of micro level interactions, interventions, etc. And to account for this verticality, we need to take a different perspective, not necessarily a perspective like the growth regression model that I showed you, which is an aggregate analysis of statistical associations, but we have to come up with a way to account for this verticality from bottom up. And fortunately, complexity sciences has already looked a lot into these kind of problems and has created a lot of methodologies to address this. That takes me to ask you if you are convinced then that we need such a complexity approach or not. And if you are not, then let me give you an illustration of what I mean by this micro to macro and the challenges with addressing these problems. So I want you to think of a government illustrated by this building. This government is a government agency in charge of setting the budget. And this government has to spend across these different policy dimensions, illustrated by the SDGs, by some of the SDGs. So let's assume that the government increase expenditure towards the quality of education. So with this, by financing an existing government program, the government aims at impacting certain indicators. One could be, again, literacy rates, and there could be the PISA tests, for instance. But as I said, many times these programs are highly inefficient. And by inefficiency, it could be there is a lack of capacity from the institution to implement the programs. There could be corruption, so there is diversion of public funds. all sorts of things. This means that outcomes do not necessarily reflect what is invested in the programs. And we know this is not new, obviously. And for that, governments have public procurement mechanisms that seek to monitor the performance of these indicators, that the resources are adequately used. They audit the policymakers, and with this, governments can build expectations of what would be the impact if I inject resources in this policy issue. Well, that would work in an ideal world, but because these different policy dimensions are interdependent, we have spillover effects. So now I want you to imagine that this hypothetical situation in which a government poured money in the Ministry of Education takes place in a program that is targeting rural communities. And at the same time, there were important improvements on the side of public health of those rural communities and also public infrastructure. So let's suppose that now all the kids in those communities are receiving all their vaccinations, which means now they will be healthier. And also that there are new roads that can take kids through public buses to their schools, so they don't need to walk for hours in dirt roads. These two factors will have an impact, a positive impact in the performance of the kids. And these kids will perform better, obviously, in the PISA tests. And the government, if the government cannot account for these interactions, obviously the government would assume that this is a result of this injection of resources. Well, this is not the case. And even worse, suppose that the agent in charge of implementing these education programs has some perverse incentives. So they have incentives to divert funds. Well, if their performance is being inflated by these spillovers, this could exacerbate the incentives to divert funds and actually turn this expenditure into more inefficient. Now I want you to picture the situation in a bigger system where we have many policy dimensions, not just 17, but many more. And there are all sorts of spillover effects. So how can we account for this in empirical models that can establish this link between public expenditure and development indicators? That is exactly the challenge that we try to tackle with this project, with policy priority inference. But before going into that, let's reflect a little bit in whether we are using the right tools to address this problem. I already elaborated on the growth regression models and their limitations. There are alternatives. There is systems thinking, for example, coming from the tradition of systems dynamics. These are computational models about stocks and flows. When one can think about a system and as a collection of stocks and then flows between them, this allows to account for loops and backpropagation effects. But these are very aggregate models again. So it is difficult to establish that link between expenditure and indicators. There is also the idea that networks by themselves capture the complexity of a system. And while networks are very important to understand structure, networks of aggregate indicators are insufficient because in the end, they suffer of the same problems as the growth regressions. These are aggregate statistical associations. We are not dealing with the verticality of the system. There is machine learning, of course, which is great for prediction, but probably for a policymaker, it will be more difficult to trust as it's not really transparent about what are the data generating mechanisms connecting expenditure to indicators. So the proposal in this research program is that we need agent computing, which some of you might know as agent-based modeling or multi-agent systems or individual-based modeling, depends from what discipline you come from. But the simple idea here is that we need to simulate agents implementing the policies that eventually affect the indicators. Now, you may be wondering how popular is this methodology in this community in sustainable development. Well, it turns out that agent computing is not new, has been around for a while, is popular in fields like human geography for spatial models, traffic analysis, conflict simulation. But in sustainable development is practically unused. And there is a survey from 2015 where the authors looked at a very large set of policy reports and government documents to look at what type of computational models they were using. And the result was that less than 1% use agent computing. So it's very little. And they qualify then this technology as just promising, but without clear benefits. And I can see the reason for that. Because when you have a tool that allows you to specify individual agents, it becomes really a challenge to find the right level of aggregation, the right specification. It would be impossible to model an entire economy with all accounting for all these policy dimensions, right? Like every individual household, and account for inequalities, gender inequalities, environmental interactions, etc. However, what we do in this program is to perhaps not go so deep in the disaggregation, but stay at a middle level and rather try to focus on a level in which we can use data, in which data can be useful, so the model can be useful for inference. And that's policy priority inference. And I want to kick off the presentation of PPI first by just telling you in the real world, how does this problem look? So this is a document from Mexico, from the national Mexican government that was published in 2019. It is a national development plan of a government that took office by the end of 2018. By law in Mexico, any new government needs to publish such plan. The plan conveys the different goals that the government would want to achieve in 6 years. The term lasts 6 years and there is no re-election allowed by the Constitution. So in this particular document, the government declared 200 objectives of different policy dimensions that it wanted to achieve. 60 out of those 200 were quantified through specific indicators that have been constructed throughout the years by the Statistics Institute. And an innovation is that all these indicators are mapped into the SDGs and that there is also budgetary data about this. This is an extract of the document. Obviously, it is in Spanish, but I think it's quite self-explanatory. These are extracts where specific indicators and objectives are declared. So this, for example, this box on the left side describes an indicator for the emission of carbon dioxide. It declares the baseline that they registered in 2016, and then the goal that they want to achieve by 2024. So they want to halve the amount of emissions. And you can see similar indicators in the document that have to do with energy or with public health or with informality for the labor markets. So with this kind of data, so we have indicators, we have budgets, and we have goals, then we can elicit a few interesting questions that many policymakers would find valuable. For example, if we would have a tool to establish this expenditure indicator link, could we assess how long will it take to the government to reach those goals? If we can do that, then can we say anything about how realistic or feasible they are? What about the budget? Is the budget that the Congress approved coherent with such goals, or could we reconfigure it to find an optimal one? And if we can find an optimal configuration of the budget, then would that allow us to identify the topics that are insensitive to budgetary changes and those that are sensitive? So can we identify bottlenecks of development and accelerators? And the tool that we designed, I don't want to go too deep into technical details, and I'm very happy to answer any questions in the Q&A. Instead, what I want to give is just a broad schematic view of the model, in the sense that there are the two levels, the macro and the micro. In the micro level, we have an agent that represents the central authority that has to reallocate the funding to different policy dimensions. In the applications, each policy dimension is assumed to be one indicator. So we can have 100 to 200 indicators. And in charge of the public policies of each one of those indicators, we will have public servant agents. So the public servants receive the funding from the central authority. Then they might have incentives to divert funds or not. The remainder of those funds that they decide to put forward the policy impact the indicators with a probabilistic connected model. Then there are spillover effects through a network that you as the user provide to the model. So the model doesn't infer the network, it assumes it as an exogenous structural characteristic of the system. And this feeds back to the government, which evaluates the performance of the indicators and decides whether to reallocate or not, and also to punish those public servants that were highly inefficient if they are discovered. And in all this, you have public governance parameters that affect how good is that monitoring mechanism. This is heterogeneous, obviously, very heterogeneous across countries. That means that we can impute some, perform some counterfactual analysis by monitoring, changing the quality of the governance, for example, or changing the way how rigid is this reallocation process of the government, or by changing the network, by changing the amount of resources available, etc. And we can extract different inferences about the system at different levels. We can look at individual agents and see how specific policies are performing, or more aggregate stylized facts about the indicators. And the logic is that with this, we have a generative model that accounts for the different interventions that the government can take in terms of budget. So we're focusing on public expenditure. And we're accounting as well for the potential inefficiencies that may arrive. The fact that many of these inefficiencies are incentivized. So there is a behavioral model behind the agents that are becoming efficient. There are institutions that try to notch these incentives. And finally, there are these interdependencies that are very difficult to account for with other frameworks. The idea is that we're going to calibrate this model. There are parameters for each indicator. We will calibrate them so that we can capture a couple of features from our sample of indicators. Primarily, we are looking at the volatility of the indicators and the trend, whether they are improving or worsening. Once we're able to capture those two things, we have basically a model that explains a data set from a much more nuanced point of view when we think about causal mechanisms. So once the model is calibrated, then we have a tool to perform counterfactual analysis. Counterfactuals could be either in a retrospective scenario, if we would want to keep studying a sampling period, or it could be in a prospective scenario, which is very common in the SDG literature, where we want to simulate indicators forward in time to see where a country is going to be by 2030. And by counterfactuals, I mentioned a few in the previous slide. The most interesting to us have to do with the modification of the budget. And something that is different compared to other tools that are out there for SDG analysis, for example, from systems dynamics and all these sort of tools, is that we focus on the short-term analysis. Longer-term analysis is beyond the scope of this tool, as one of the assumptions that we have is that the policies that exist right now are going to remain the same. And that is because redesigning a policy program or coming up with a new government program, that is a longer-term task. It is a structural change. So we're going to look more at the changes coming from financial problems of redistribution of resources. And something that we achieve as well is the ability to cope with expenditure data to establish this link. New expenditure data is coming available that is very disaggregated, that you can almost make a perfect match between the indicators and the expenditure data. Is the frontier in this field. And it's mainly Latin America where this is happening for some historical reasons that we can discuss afterwards. And importantly, because we can simulate data, we don't need to pull cross-national countries together. We don't need a panel. So we can estimate the model for individual countries, and that allows us to keep context specificity. Likewise, we can use the network that you estimate for different countries so that the network in itself also captures some of the context specificities of the different nations. And at the end, I will explain how this tool can complement very well existing analytical tools that governments have at their disposal. So in a nutshell, you can think of PPI as a model, a computational model, where you provide some data. You need development indicators, that is a must. And these three are optional. So you might provide goals if you have them. You might provide a network if you have it or not. And the budgetary data as well. You can provide very disaggregated data. If you don't have it, you can still do certain inferences. And these are some of the things that you would get out of it. Now to the applications. The first project that we did was with Mexico. So this project was sponsored by the United Nations Development Program, who has the mandate of concentrating much of the activity that is happening around the SDGs. So they contacted us after they saw our first publication, which couldn't address the SDGs, because in the SDGs you could have negative relationships between the indicators, right? If you increase very aggressively industrialization, it will be probably at the cost of the environment. So we could not address that back then, and they asked us if we could improve the methodology to do that. So we did, and that project was in collaboration with the Mexican government. and several local governments as well. And one of the insights that we were able to produce is precisely this idea of how realistic are the goals that are reported in that national plan that I showed you. So what you see in this graph is in the vertical axis, you have the number of years that it would have taken to achieve those goals. Each one of these markers denotes an indicator. They are colored according to the SDG that they belong to. If you see a star, it means that these indicators have very well identified government programs that are designed to impact them. This is what we call instrumental indicators, because there are policy instruments. But there are also indicators of development that are not directly impacted by the government. For example, because there is no program available. The most obvious example for me is cybersecurity in sub-Saharan Africa. Cybersecurity really today in that region of the world relies mostly on the private sector, not on government programs. Another could be GDP. GDP is a very aggregate variable, and no government could claim that they have a particular program with which they can almost manipulate it. It is a result of many other economic processes. So those are the circles. And what you have here, the real result is obviously that it would take more than 10 years to reach those goals. There is heterogeneity. Some indicators would reach very fast, some would not. But the idea is that in the short term, in the term of a government of 6 years, it is unfeasible. It is an unfeasible program. But it is not, from our experience, we would say that it is not crazy unfeasible, because 10 years is just less than 2 terms. So, you know, if the same political party gains again the election, there is a possibility of reaching the goals. Now, this study was before the pandemic, and things have changed drastically since the pandemic, so this would be probably revisited soon. In particular, on the side of poverty, because during the pandemic, in particular, Mexico was heavily hit by in the poverty dimension of development. Something interesting that we can do then is, because we have also budgetary data that is classified to the level of the targets, not at the level of the indicators, but at the level of the targets. With that data, what we can do is perform counterfactuals, exploring better configurations of the budget. So we try to find an optimal configuration using a different set of tools that come from evolutionary computing. They're called, some are genetic algorithms, some are differential evolution, and they're heuristic optimization tools. So once you derive this optimal distribution of the budget, and it's optimal in terms of minimizing the time to reach the goals, then you can compare that budget against the one in the real world. And this comparison is reflected in this graphic. So in the horizontal axis, you have our optimal budget, and the vertical, you have the real one. If a dot, and these are budgets aggregated at the level of the SDGs, by the way. So if you have a dot above the dashed line, it means that the government is overspending with respect to our optimal allocation. If it is below, it means that it is underspending. And a couple of years later, we found out that it was quite an intuitive result, because this yellow marker, for instance, is SDG 7, which has to do with energy. And it is well known that the government today has had a very aggressive strategy towards spending very heavily in carbon-intensive technologies, more than what it would have needed to arrive to the goals proposed in the National Development Plan. And then you can do all sorts of things with these quantities. We actually construct an index for measuring policy coherence. And policy coherence is a very popular topic in the development community, yet it has never been quantified before. So with this, the index can tell you how coherent is your budget, and in other words, your actions with respect to the goals that you want to achieve. We did another analysis at the subnational level. This was interesting because Mexico is a federation composed of 32 states. Here we have colored them according to their level of development, being the green ones the most developed and the gray ones the least ones. Here the difference in development is very big. So to give you an idea, the northern states that are in green have levels of development of some European countries, developed European countries, while the ones from the south in gray, their level of development is very similar to Central American nations. And because of this heterogeneity, the federation has always had the principle of redistributing federal transfers to try to close these gaps. And this is important because most of the income of the states in Mexico is from federal transfers. So in contrast, for instance, from a federation like the US, in which the states have a lot of power in collecting taxes, in Mexico, they collect almost no taxes. So they have no collection power, but they can spend most of the transfer that they are given. So the question is, if we want to bridge these gaps, are we allocating the resources in the best possible way, these federal transfers in the best possible way across the states? And then we challenge a mathematical formula that is in the law that determines the distribution every year, is the Fiscal Coordination Act. And we find that for the most part, it actually is quite coherent, except that probably some states should receive more transfers, while others like Mexico City or the state of Mexico, which are the most populous, would probably use a bit less. And it just happens that these two states are the ones who are able to collect most taxes on their own. So the transfers proportionally represent much less income compared to the other states. We also developed a project with the UNDP and Uruguay. In Uruguay, they were interested in learning what are the accelerators. So what are the topics in which if they invest, they will catalyze development across the board. So we have again applied these heuristic optimization methods. The exercise here was, what would be the set or the subset of indicators that would be the best if we want to relocate only 10% of the budget? And the result is this: the red stars are the ones that we find as the optimal subset of indicators. And this is interesting because this optimal subset means that they are not only receiving an additional 10%, but those black stars were taken away resources, and the cost in terms of delays, which is in the vertical axis. So vertical axis upwards means savings in years to reach the goals, and downward zero negative means years delayed. So as you can see, the black stars have very little delay at the cost of great savings for many indicators. Well, then we went to the local authorities of Peru in the capital, Lima, and they were interested in the other side of the coin, not in accelerators, but in bottlenecks. What are those topics in which the local authority cannot move, even if they increase the budget in significant ways? So we created a counterfactual that we call the frontier analysis, in which you can increase unlimited amounts of budget. And what you want to see is to detect those indicators that have the least sensitive response to those budgets in increments. And if you have that scenario, if you have that situation in which you detect an indicator that responds almost nothing, it could be for two reasons. One, there's a bottleneck, so the programs in place are not working, they're highly inefficient. Or two, the indicator is already very good. So for example, you already cover 95% of electricity in Lima, and that 5% additional is very difficult to get. So this plot captures those two dimensions. So the number of months saved, so this is with respect to some goals that the government wanted to achieve, that's the vertical axis. And the horizontal axis is the historical performance of the indicator. So the gray area is the one that captures these potential bottlenecks because they have not been performing great and they show insensitivity to the budget. So this means that you have to raise some flags here and bring some experts to look at the specifics of these programs. And this is where the methodology can complement with other expert advice, and I will elaborate on that in a bit. We did also some optimization exercises. The idea here is that the authority projected a growth in their budget, and they wanted to know, with this additional budget in the next 5 years, what is the best reallocation? And they asked us to do two scenarios, one in which we cannot allocate less than what they have historically allocated. So that's the left one, is a conservative. You cannot decrease below the historical levels. And the right is the flexible. You can decrease. And the reason for these two scenarios is because politically it can be very sensitive if you decrease certain topics, for example, poverty. In Latin America, you don't want to decrease poverty. It is politically risky. This is another project that we did with Colombia. Here I'm just putting the link, and it will be in the slides when I share them. Here you can see this an interactive portal in which you can click on the analysis to look at detecting bottlenecks again for the national case of Colombia. And all this collection of exercises eventually can be collapsed into decision framework that we provide for the policymakers. And it's conveyed in this, again in Spanish, and I apologize, but I will explain this decision chart. So suppose you have an indicator that is strategic for your department or agency, and you want to learn from this. What do I do with indicator? Should I just leave it as it is because it's very good? So this would be this decision. Should I maybe just change the budget because indicator responds and it's just a matter of a financial decision? So that's the second. And the third one is the indicator doesn't respond. It has performed very bad historically, so I need to call an expert and look at more detail of what is going on. And this is when we bring other methodologies. Perhaps you want an expert in poverty. Perhaps you want to design an experiment. Perhaps you want some anthropologists to look at things like the role of kinship in social networks and how this impacts conditional cash transfers. I don't know, many possibilities. But the first step to detect where are the problems can be provided by this methodology. And the idea is that you subject the indicator to this series of analyses. You look at the projections, if they would reach the goals in time or not. If they do, then you don't do anything. If they don't reach, you do this scenario, the frontier analysis, to see how they respond to very large budgetary increments. If they respond well, so if you save X amount of time here, 5 years, then you just adjust the budget according to the optimization exercises. If it doesn't respond, then you check if this is an indicator that is historically bad or not. If it is bad, then you have to look into redesign and structural changes. Finally, just on the academic side, so there are many publications from this work. I invite you to look at them. This is an analysis that we did globally to look at what are the bottlenecks across the SDGs around the world. And you can aggregate these bottlenecks across countries or SDGs and various combinations. Our estimates are very disaggregated, so you can do a lot with the data we produce. A recent paper that I'll make publicly available probably this week is on international aid and a method to actually estimate the impact of aid, again, in a very nuanced way of specific indicators in specific countries. This is something that has not been done before, and it cannot be done because of the nature of the methods and the data available. And I invite you as well to look again at the academic papers, the technical reports, the UNDP. We have GitHub repositories with Python code if you're interested in hacking it or just playing with it. We also have Jupyter tutorials to walk you through many of these libraries. And we also provide workshops if anyone is interested. We're very flexible to train people. We have also some materials like the one you are seeing here, explainer videos. A book in preparation, hopefully will come out next year, collecting all these experiences, all this method data, etc. And the coolest of all is that we're currently developing an app, because when you want to bring computational social sciences beyond academia, when you want to bring it to the stakeholders, you need to do a lot of work in translating it into friendlier tools. And even if Python for some of you might look as a very friendly language, it is a very, very high entry barrier for many agencies, especially in developing countries where capacity is an issue. So we're developing an app in which you should be able to run a simplified version of PPI in your web browser with certain data that you can upload. And hopefully I have news on that in a month or so. A thank to all the organizations that have been supporting this, to my collaborators, Gonzalo and Daniele, my postdoc at the Turing. And to close, just if you are more interested, my research group is working on all these topics. Together with Daniele, there are other 6 postdocs with very ambitious research plans, and very excited to collaborate with people beyond the Institute. So we are all ears to hear your ideas and proposals. Thank you very much for having me here. I hope I didn't bore you, and I'm very happy now to engage in a Q&A.